Hi there, and welcome to OLAGOLD Academy. For today, we are considering these questions on the board, and these questions are under a topic which is mole concept. Now let's see how we can solve these questions here. Question 1 says that what volume of CO2, which is carbon dioxide or carbon dioxide, is produced at STP when 50 grams of limestone reacts completely with excess hydrochloric acid, which is HCl, or hydrochloride, or hydrogen chloride. So calcium is 40, carbon is 12, meaning that the atomic mass of calcium is 40, atomic mass of carbon is 12, GMV, which is given molar volume at STP, equal to 22.4 dm3. And we have this as the equation. So we are having calcium carbonates reacting with hydrochloric acid to produce calcium chloride, water, and carbon dioxide. Alright, so let's see how we can solve this question. Solution. Now, one thing you take note of is that 1 mole of any gas occupies a volume of 22.4 dm3 at STP, and 1 mole of any gas occupies a volume of 24.0 dm3 at RTP. The full meaning of STP is standard temperature and pressure, and the full meaning of RTP is room temperature and pressure. So if we check this question carefully, this question has to do with a chemical equation. So whenever we see a question having a chemical equation, it means that we are going to use the chemical equation to go about the question. So bringing out the chemical equation, we have calcium carbonate, which is another word for limestone, reacting with 2 moles of hydrochloric acid to produce calcium chloride, water, and carbon dioxide. Let's check if the equation is balanced. 1 calcium and 1 calcium, 1 carbon and 1 carbon. We are having 3 oxygen. We are having 1 oxygen here plus 2 here, making 3 oxygen. We are having 2 hydrogen here, and we are having 2 hydrogen here. 2 chlorine here, and we are having 2 chlorine here. So this equation is a balanced equation. Our next step is to check what the question is talking about. What volume of carbon dioxide is produced? If you check this question carefully, you can see that the question is specifying on carbon dioxide. Let's continue. It's produced at STP when 50 grams of limestone. So as you can see, we are seeing 50 grams of limestone, which is calcium carbonate. When 50 grams of limestone reacts completely with excess hydrochloric acid, one thing you take note of is that in mole concept, when it comes to you having chemical equation, no matter how long the question can be, your attention will be drawn to just 2 of the substances in the equation. It might be 2 from the reactant side, or it might be 1 from the reactant side and the other one from the product side. That is how it usually comes. It's either it comes from the 2 at the reactant side, or it comes in the form of 1 from the reactant side and the other from the product side. So if we check this question carefully, we can see that, remember I said that your attention will be drawn to just 2. Just 2, not 3, just 2. What volume of CO2 is produced? And let me add something. To identify those two substances, one must be the unknown or must be in question. I repeat, one must be, one of them, let me say, one must be in question, and the second must have value. These two are what we use to identify the two substances that the question are specifying on or is specifying on. The first one must be the one in question, the unknown one. It comes in form of what volume of, calculates the volume of, what mass of, calculates the mass of. So it must be in question. And we check here carefully, you can see that what volume of CO2 is produced. So it means that one of the substances is CO2. And I said that the other one must have value. If we check carefully, we are saying that what volume of CO2 is produced at STP when 50 grams of limestone, which is calcium carbonate. As you can see, we are saying that limestone has value, as we can see, you can see that limestone has value, as we can see that limestone has value which satisfies this condition, and we can see that carbon dioxide is in question because we are saying what volume, which makes carbon dioxide to satisfy the first condition. So it means that we are talking about, or the question is specifying on carbon dioxide and calcium carbonate, which is limestone. All right, so let me take this side off. Let me take this off. So we have this. From this equation, we are having calcium carbonate, and also we are having carbon dioxide. So these two are what we are dealing with. My next step is to check what is the parameter for these two substances. Are they in volume or they are in mass? Carbon dioxide, the parameter is volume, because it says that what volume of carbon dioxide. Limestone is mass, because I'm saying 50 grams. How to go about this question is to check the equation, check the mole ratio. As we can see, 1 mole of calcium carbonate reacted with 2 moles of hydrochloric acid to produce 1 mole of calcium chloride, 1 mole of water, and 1 mole of carbon dioxide. So we are having 1 mole here, and we are having 1 mole here. So it means 1 mole of this is used in the reaction, 1 mole of this is produced. Let's continue. After I've done this, my next step, like I said before, is to now bring out that parameters that they are being given in from the question. What volume of CO2? We check here, we are seeing STP here. And I said that 1 mole of any gas at STP will occupy a volume of 22.4 dm3. So it means 1 mole of CO2, according to this volume here, will occupy a volume of what? 22.4. Because carbon dioxide is a gas. So you have 22.4 instead of 1 mole. In the place of 1 mole, we have 22.4 dm3. Alright, let's check for limestone. I said we have mass for limestone. So in the place of mole, I'm going to put mass there. How do I go about that? I need to find the molecular mass or the molar mass of calcium carbonate. To find that, I have this number and mass. For the element I'm having here, I'm having calcium carbonate. So I have calcium, I have carbon, and I have oxygen. How many calcium do I have here? I have 1 calcium. How many carbon do I have here? I have 1 carbon. How many oxygen do I have here? I have 3 atoms of oxygen. I have 3. Multiplied by, and multiplied by. My next task is to check the atomic mass of calcium. It's given as 40. I have 40. Carbon is 12. Carbon is 12. What about oxygen? Alright, it's not there, but oxygen is 16. The atomic mass of oxygen is 16. So I have 16 here. My answer here is 40 is 12 and is 48. 1 times 40, 40. 1 times 12 is 12. 3 times 16 is 48. My next step is to add them together. So I will have 100 here in total. So I have 100 gram. I have 100 gram. So in the place of 1 mole, I'm going to put 100 gram. Since the parameter from the question is mass, I'm going to have 100 gram. So I'm trying to say that 1 mole of calcium carbonate is used in the reaction to produce 1 mole of carbon 4 oxide. So I'm saying 1 mole of this produce 1 mole of this. But in the place of 1 mole, I used 100 gram because the question says that 50 gram of limestone. And in the place of 1 mole here, for carbon 4 oxide, I have 22.4 dm3. Since the question says that what volume of carbon 4 oxide, so I apply the parameters to satisfy the question. So my next step is to now check the question. What volume of carbon 4 oxide is produced at STP when 50 gram? What volume is produced when 50 gram? So it means that when we use 50 gram of limestone, what volume of CO2 will be produced? When we use 100 gram of carbon, when we use 100 gram of CaCO3, we get what? 22.4. So if we now make use of 50 gram, what volume of CO2 are we going to get? Let me say it again. When we used 100 gram of calcium carbonate, we get 22.4 dmq. Now the question is saying that if we make use of 50 gram of limestone, what volume of this we produce? So if you make use of 50 gram, if you use 50 gram of limestone, what volume of carbon dioxide will be produced? That is the question there. If we check carefully, we can see that if we check carefully, we can see that 50 gram is half of 100. Check carefully. We used 100, we get 22.4. If you use half of 100, it means that half of this also will be produced. So it means that if you use half of 100, half of this also will be what? Will be produced also. So let's continue. My next step, since I have this, my next step is to cross multiply. This one will come to meet this one, and this one will come to meet this one here. This one here. So I'm going to have x times 100 gram equal to 50 gram multiplied by 22.4 dmq. From here, I'm going to have 100 gram x equal to 50 gram multiplied by 22.4 dmq. My next step is to divide both sides by the coefficient of x, which is 100 gram. So over 100 gram, and here over 100 gram. So 100 gram here 1, 100 gram here 1. So if I check here, gram cancels gram, 50 here 1, 50 here 2. So I'm going to have x equal to, up here, I'm having 1 times this, so I'll get 22.4 dmq over, down here I'm having 2. I have 2. So if I divide further, I'm going to get my x to be what? My x to be what? 2 going in, or let me say 22.4 divided by 2. I'm going to get what? 11.2. So I'm going to get 11.2. 0.2 what? dmq as my final answer. So as simple as this. As simple as this, please. As simple as this. As simple as this. Your first step is to bring out the chemical equation. After that, check the two relating substances. And I said that the first one must have value and the second one must be in question. So bring them out. After bringing them out, then apply the question or bring in the question. After bringing in the question, then solve. After solving, you get your answer. As simple as this. As simple as this. So now let's quickly look into question 2 and see what we are going to get in question 2. Okay, let's solve question 2. Question 2 says that calculate the mass of zinc sulfate produced when excess of zinc carbonate is added to 50 cm³ of 4 mole per dm³ H2SO4. Zinc sulfate is given as 161 gram per mole, and we have the chemical equation written as this. So as usual, our first step here is to bring out the chemical equation. So we have zinc carbonate reacting with tetraosulfate 6 acid to liberate zinc sulfate, carbon 4 oxide, and water, which is H plus carbon 4 oxide plus H2O. We have this. Our next step is to check if the equation is balanced. One zinc here, one carbon here, one carbon here. We're having 7 oxygen here, 3 plus 4, that is 7 oxygen. At this side, we're having 4 plus 2, which is 6, plus 1, which is 7. At this side, we're having 2 hydrogen, also. 1 sulfur. It means this equation here is a balanced equation. Our next step is to bring out the 2 relating substances. And remember, I said that one of them must be unknown and the other one must have value. I said that no matter how much substances or how many substances you have on the equation, your attention will be drawn to just 2 of the substances. The first one must be in question and the second one must have value. We check here carefully. What is the question saying? It says that calculate the mass of zinc sulfate. So what does that tell us? It means that zinc sulfate is one of the 2 substances. And where is the zinc sulfate? This is zinc sulfate. So it means that you must be able to identify chemical compounds when you see them. Zinc sulfate produced when excess of zinc carbonate. As you can see here, zinc carbonate, though it is appearing in the question, it has no value attached to it. It's only saying that when excess of zinc carbonate, and it stops there, is added to 50 cm³ of 4 mole per dm³ H2SO4. So it means that H2SO4 is the one that is having value. So that is the second substance we are talking about that is related to zinc sulfate in the question. So next we are having H2SO4. And here is H2SO4. So you have H2SO4. So we have this. As usual, let's check the mole ratio of this chemical equation here. 1 mole of zinc carbonate reacted with 1 mole of H2SO4. So I have 1 mole here. So liberate 1 mole of zinc sulfate. So I have 1 mole. And 1 mole of carbon 4 oxide and 1 mole of water. So for these two substances that I'm talking about or that I'm solving on, the two of them are having a mole ratio of 1:1. My next step is to check the parameters that these two substances are being given. The question says that calculate the mass of zinc sulfate. So it means that the parameter for zinc sulfate is mass. I'm to express zinc sulfate in mass. I'm to express zinc sulfate in mass, meaning that it must have the unit for mass. If we check here, we are given zinc sulfate to be already 161 gram per mole. So this is the value in mass for zinc sulfate. So I have, instead of 1 mole, I'm going to write 161 gram per mole. I'm going to write this. So it means that 1 mole of zinc sulfate in mass, it is 161 gram per mole. But in mole, it is what? 1 mole. But in mass, it is what? 161 gram per mole. Let's continue. When excess of zinc carbonate is added to 50 cm³ of 4 mole per dm³ H2SO4. Very easy. This value might seem confusing to us, but it's very simple. What they are asking us to do in this question is to find the mole. And how do we go about that? Let's bring this out. 50 cm³ of 4 mole per dm³. 50 cm³ of 4 mole per dm³. Very easy. What do we do? Just express this 4 mole per dm³. Just express it out. So you have 4 mole in 1 dm³. If we have 4 mole in 1 dm³ and you have 50 cm³ here, how many mole are we going to get? We have this 50 cm³, 1 dm³. So what do? I need to convert dm³ to cm³, and that will give me 1000 cm³. Just express it this way and you have no problem. 4 mole in what? 1000 cm³. Remember, it is 50 cm³ of this. So I'll just put the cm³ under where it belongs and look for the mole. Express it this way and you have no problem at all. My next task is to cross multiply this and this. This comes here, this comes here. So I'm going to have x times 1000 cm³ equal to 50 cm³ multiplied by 4 mole. 4 mole. I have this. My next task is to divide both sides by 1000 cm³, since it is the coefficient of x. So that will be over 1000 cm³ over 1000 cm³. If I multiply this, I'm going to get 1000 cm³ x. So this year 1, this year 1. cm³ cancel out cm³. What next? X times 1 will give me x equal to 50 times 4 will give me what? 200. So I have 200 over what? Over 1000. 1000. So 0 cancels 0. 0 cancels 0. So I'm going to get my x to be what there? 0.2. Yes, remember, here is mole. Here is mole. Mole is remaining here. So we have 0.2 mole here as my expression for 50 cm cube of 4 mole per dm cube. So I have this. So let me take this side off now. Let me take this side off. Alright, so I have this as my expression for 0. So I have this rather as my expression for 50 cm cube of 4 mole per dm cube H2SO4. Alright, so it means that from my calculation, it means that the parameter for H2SO4 is mole. The parameter is mole. So I will just leave this 1 mole as 1 mole. I'm not changing it because it means that I'm going to use 0.2 mole as my representation over here because the question is expressing H2SO4 in mole, not mass and not volume. So I'll bring I'm going to bring 0.2 mole here. So I have 0.2 mole. And I'm going to have X here. Because the question says that calculate the mass of zinc sulfate produced. So I have this here. So from the equation, 1 mole of zinc, from the equation, 1 mole of H2SO4 produced 161 gram of zinc sulfate. So what's the question now? What mass of zinc sulfate will be produced if we use 0.2 mole of H2SO4? So my next step here is to cross multiply. So you have this times this. So x times 1 equal to 0.2 multiplied by 161 gram. So x times 1 give me x equal to 0.1 times 161. 0.2 times 161. I'm going to get what? My calculator. 0.2 times 161, I'm going to get 32.20 gram per mole. So this is my final answer. 32.20, yes. So I have 32.20 gram per mole as my final answer. So it means that this is the mass of zinc sulfate that we produced when excess of zinc carbonate is added to 50 cm cube of 4 mole per dm cube H2SO4. So we are going to have this as our final answer. So you can use this explanation from this video lesson to solve any calculations that involves chemical equation under the topic of mole concept. So I'm going to do more videos on the calculation of mole concepts in the next video. So if you find this video helpful, if you know that you gain value from this video, don't forget to support us by hitting the like button, dropping a comment, and also subscribe to this YouTube channel. So thanks for watching. This is OLAGOLD Academy. So we'll try to bring more helpful videos like this to you. So you do have to turn on the notification icon. So thanks for watching. Bye.